I'm Kaijan. All right. We're gonna talk about Qiling framework today. So together with me, we have Simone. Okay, I call
Correct.
him
Yeah.
Sim1. So look at his name. It's Simone. Sim1. So I got the pronunciation.
It's correct. It's
And
correct.
be serious. Okay, we are doing live stream right now, so don't laugh. Okay. So, this is me, all right. All these years I've been calling myself X-Wings. Everybody know me as X-Wings. So, I work for this company, JD.com, in the security department, and I design quite a fair bit of patch for mostly hack in the box, and actually only hack in the box and nobody else. So, this year is the lockdown edition, so we don't have any patch available for anyone. I mean, I can do one for myself, but that is not fun. Since last year, I've been working for Qiling framework, and this is a thing that we're gonna talk today. So this is pretty much about myself and the rest of the team that will be. So what do we have over here? It's these are a few of the teams that we have. And we have of course the most of the work is from the community. Okay, and the oh I am the mastermind, but we have the big evil advisor. That is Queen, the one that built Unicorn Engine, the one that built Capstone, the one that built Keystone. All right, I know for sure he's listening right now, and it's the control freak. I just want to put my complaint right over here since he's listening right now. So that is Queen that builds a Unicorn Engine. We call him the professor within our group. Okay, so what do we have here? It's we're gonna talk about the agenda. So I know you guys saw the Star Earth thingy, but yes, the agenda is pretty much about the motivation why we want to build a Qiling framework. Okay, and all the way until the conclusion. So right before we go on, okay, please like our project, give us a little bit more star. We are suffering, we are hungry, and we are feeding on GitHub star. So please do us a very small favor. Quinn just sent me a message and says, what the fuck? So, all right, he heard us. Okay. So, for the we're gonna talk about a bit on a Unicorn emulation framework. So what we have over here, it's a Unicorn is actually a CPU emulator, and this is the base of our entire project. Okay. So, but the only limitation here, it's Unicorn cannot handle any files. So if you look at the screen next to me, the little black screen over here, they can only emulate what we call it as a CPU code. So you put in an address, you put in a register, and then you put in all necessary information like how much RAM you want to have and what kind of condition you want to execute a code, and it will execute the opcode according to your settings. So that is a Unicorn engine. But if we need to bring these features into next level, that is quite a fair bit of job we wanted to do. Okay. So how we actually got this project started. All right. So this is a very fun story for us to share. So how we actually get into this entire project, it's we started with shellcode, right? Like what I mentioned just now. So I have been throughout all these years in corporate, I have been receiving quite a fair bit of funny binary codes from the security monitoring teams. So and then I have this idea: why not we should build something? Why not we should build something to analyze the shellcode? So I mean, me and the founder of Unicorn Queen has been friends for so long. So I always wanted to build a fairly large and a nice project with Unicorn. So I was like, we should have a shellcode framework or a tools to execute a shellcode. So this is how we all got started. So how to translate a bunch of opcode into a human readable format or a more informative report. That is what I wanted to achieve, and it should be automatic, and it should be as easy as we can run it just like that. So and why we wanted to analyze shellcode? The only reason is shellcode gets more complex from day to day. So we are looking at a very simple shellcode that which is on my left. Okay, you can see no, your left, my left. We can see a very short shellcode and until a very complicated shellcode. The only reason is shellcode gets complicated because of the environment gets more complicated. Windows get more complicated, antivirus get more complicated. Okay, network detection tools will get more complicated. IDS firewalls will get more complicated. They can do more things. So shellcode designed to evade all this kind of detection. That is where to analyze shellcode is a very important task. Of course, lazy people like me, before we are always, when we always wanted to start a new project, we will not start a new project. We will go out and hunt. We will go out and hunt for a project. So what we are trying to do over here is we discovered this project called UserCon. All right. Very, very good project. But the only thing over here, it's limited to OS supports. I mean, we know that when we receive shellcodes, it must be, for corporate security purposes, we need to have something on Windows and not only Linux. The bad thing is UserCon only runs on a Linux platform. It only emulates Linux platform, so that it's not exactly what we wanted to what we wanted to use. Okay, and like I always say, Golang, it's not really a hackers friendly language. It's a very good language. Okay, I'm not condemning this Golang, but it's when there's a CDF player, when there's a hacker, everybody goes to will know Python, and not everybody knows Golang. So that is one of the reasons we were thinking we should rebuild this entire project. All right. So what is required over here? It's we always want a good debugger. We always want a good disassembler. That is something that we really need. All right, and it always goes to a second level where how many OS we want to support. Do we want to support the BSD series? Do we want to support the Linux series? Do we want to support the Mac OS series? So when I say the Mac OS, it's including iOS and the latest and the famous iPad OS. All right, and of course the last one is we must support Windows. So when we try to design this entire framework, we were thinking that we must have a good debugger, we must have a good disassembler, of course the OS choices, and what kind of architecture that we need to focus on. So we are looking at MAPE, we are looking at ARM, we are looking at what are you doing, brother? We're looking at MAPE, we're looking at ARM, we're looking at Arch, ARM 64 and x86, of course, 62-bit and 32-bit. So if we move on, all right, then there will be the next question is why Unicorn and not the other emulators? So we look at we do look at other emulators when we compare to unicorns. We look at VMware, we look at especially things like VirtualBox, QEMU, all right, which is more flexible for us to customize. And the only issue over here that we have is all these virtualized platforms are over emulate. When I say over emulate, we are looking at things that they are emulating the display drivers, they are emulating the sound cards, they're emulating all sorts of things that we don't even need. What we really need is a CPU emulator. So Unicorn engine is still our main choice to build this platform. Of course, the next thing that you might know is the more things you emulate as a emulation engine, there's a higher chances for the malware to detect your sandbox. So that or whatever thing there is. So that is the concern that we have. So when we move on to this stage, then we realize that, okay, we need to have a emulation system which is as simple as possible. That is the reason why we go with a unicorn engine. All right. So like I mentioned just now, so if I need to build a hackable shellcode emulator or a framework, so these are the things that we need to go for. Okay. We need to have a lot of OS support. Okay. We need to have a very good assembler. All right. So, and the assembler must support a different architecture. That is for sure. Okay. And we need a good disassembler. So how can we mix and match all these things together? So this is one of the things that we really took into consideration. I mean, of course, to choose, BSD, choose which Linux to support, and then how we can build all the OS support. That is something that we really spend a lot of time on. So after that, we started with a project last year around this time, if I'm not mistaken. So it's around April. We did announce our first version of Qiling. So during that time, we call it GUA. It's a combination of we are using Unicorn engine, Capstone engine, Keystone engine, and then we have a very minimum support of we have a minimum support of FreeBSD, Linux, Windows, Apple, and then until the end of the day, we go with, Python is our chosen language. So until this stage, we thought that, hey, we got our first project. So this is how it looks like during that time. So this is how it looks like during that time. So we have a bunch of Linux ARM64 TCP reverse shellcode. So if you try to execute, all right, you just need to call the tools and then shellcode and then put in the arch and the OS and what type of file that you're going to throw in, and it will execute. So you can see it translates from the opcode all the way to a readable report or readable format. Okay, human readable format. So this is how simple we can execute a piece of shellcode. All right. So instead of throwing hex, we can actually put in a bunch of assembly code. So if you intend to develop a shellcode and then you have your assembly code, we can compile on the fly by using Keystone, of course, and then to disassemble it by using a Unicorn engine, and then to show you the Capstone engine, and then to execute it using a Unicorn engine in the backend to show you the end result. So that is pretty much how we run x86 32-bit assembly file. And then we can even execute Windows, of course. So a Windows assembly file. You try to run it, so you can see the assembly file down there as an example. And then we have how we can execute Windows code. So this is as simple as that. We even load in the DLL. So this is a very fun project for us. But until this stage, okay, right before we announce, until this stage, the only thing that we thought is we can execute. We spend a lot of time to build a Windows DLL loader, all the different kind of syscall for Windows, for Linux, for Mac, different syscall for FreeBSD. So we thought if we put a little bit more extra effort, we might able to run file. So that is what we thought originally. So, and from my imagination, I always thought it can be a 2 weeks job, since we have almost everything ready. So we just need to build a file parser, okay? A kind of a file parser. Then we should be able to run a proper exe file, a proper Linux binary or a Mac O binary. So that is my childish, unfortunate imagination. So once we finish this project, so we were like, let's go on with a more ambitious thing, But again, during that time, it wasn't too too ambitious for us. So this is the actual project, and the features that we put in after all these months, ever since the first beta release last year November, and right until now, we can support Windows, we can support Mac OS, we can support Linux, and we can support BSD. So again, when I mention Mac OS, it does include certain parts of iOS which we are still developing. It supports cross architecture, x86, 32-bit, 64-bit, ARM64, MIPS. Okay, and then we have of course, in order to run an exe file, Mac O and ELF, we must support a different file format. And we do have a different level of API setup, and then you can turn it into a sandbox. Okay, and since last February, we throw in a remote debugger, so you can fully support a GDB, IDA, and then we just discovered that you can actually run R2 on it. And Mr. Sim1, okay, he actually built in a very fun features, so we can do OS profiling. So I'm going to show you how OS profiling works later in the demo. This is one of the important features that we always wanted to have, and finally we have it with his help. Okay, of course, from day one we started to build this entire framework. Everything is on Python, so it's very easy for few kind of human beings. I mean, not limited to human beings, but anyway, any kind of people who wanted to learn different kind of project. Okay, number one is if you wanted to learn how to build an OS not from scratch, you can always look at our project and then write more syscall or write more Windows API on top of it. So this is one of the best way for you to learn how OS work. I mean, okay, so if you want to go for CTF, of course, this is a perfect tool. If you want to build an analysis platform, for IoT, for Windows, this again will be another great tools to be your foundation on top of the tools that you want to build. All right. So until this stage, the questions that I always receive is people asking, so how do you compare yourself with all the existing projects out there? So we collected some of the project that we know. I mean, some of that if the project exists and we doesn't know, then too bad, it's not on this list. But all the way from QEMU user mode to UserCon to Berni, the top 3 projects on the QEM user mode is a tools for sure. You only can run a file, and it's only a file. And they are doing a syscall forwarding. I put it in red. I will explain why later. Okay, and then a UserCon, I did mention just now, very limited OS support. Okay, and it's doing a syscall forwarding. All right. Last year we discovered that this wonderful project called Berni. It only runs Windows. It doesn't support Linux. Okay, and it's just a tools. So a tools means you can download, you can compile, and you can just run an exe file without providing additional plugin or API or whatever things from the thing. So and then we have Wine. Wine only support Windows that runs on a non-Windows platform, namely Linux. All right. Microsoft have this thing called WSL2. Okay, I'm not too sure whether we should put it in this category or not, but I'm quite sure somebody will ask, how do you compare yourself with WSL2? WSL2 is not sandbox. Everybody knows that. All right. There's no instrumentation. In fact, QEMU user mode, you don't have instrumentation. Wine, you don't have instrumentation. All right. Berni, you don't have instrumentation. And then I think last month or last 2 months, we discovered this project called Zelos. All right. They only support Linux-based, no Windows yet. And then their multi-architecture support is not complete. Okay. But they are using Python, and it's a framework. So the nearest project that one of the good projects we have seen in the market, nowadays. So I did rate and bold syscall forwarding just now. So why syscall forwarding in QEMU and why syscall forwarding in other emulation platform is not healthy? It's just because of you can only forward syscall within the OS itself. So I give you an example over here. If I wanted to use a QEMU to run FreeBSD, okay, so this is a scenario. I need to use a QEMU user mode to run a FreeBSD ELF file just to find out how does this thing work. The only way for me to do it is I need to install FreeBSD and install QEMU, then only I can emulate FreeBSD. I cannot emulate a Linux ELF file within a QEMU that installed on a FreeBSD. So you only can emulate the same OS on the targeted OS that you want to emulate. So that is syscall forwarding. So when we designed this entire project, we wanted to avoid this. So it will take us extra effort to rewrite the syscall in Python, but we will have a more proper support when it comes to a cross-platform and cross architecture. So how does Qiling work is very simple. All right. So when I mentioned about the cross-platform and cross-architecture, which means we can run on Windows, we can run on Linux, we can run on BSD, we can run on Mac OS, and we can emulate Mac OS, we can emulate all the POSIX system, we can emulate Windows. So there is no limitation on which OS that you choose and which OS we can emulate. All right. So of course, you can run on an ARM64 machine to emulate the x86 machine. So this is what we normally do on the demo. So I bring my Android pad along and we will demonstrate how Qiling works. Okay, and we can take in ELF, we can take in a P file, we can take in a P32 macro, and of course we have this loader and to set up the OS environment, and then to execute it. Okay, and then that is where you decide whether you want to throw in instrumentation or not. So instrumentation simply means you can redirect the process to your interpretation before it returns to the software and exit. So this is how you can inject code. All right, this is how you can fast the software. This is how you can understand. You can do more analysis when it comes to obfuscation or whatever thing there is. So this is what you need when it comes to be a platform or to be a framework or to be a very strong analysis tool. So we have our instrumentation built in. And like what I mentioned just now, all right, once we finish the first part of the project, all right, I am too naive to think that it's very easy for us to build a file execution system instead of shellcode. So the first thing first is we need to fix the loader issue. Shellcode, it's not a file. Shellcode is not a file, so we don't need to pass the file to set up the environment. We need to set up the environment for shellcode, but when a file comes in, we need to sort of read the file, to understand the file, to load up the file before we can execute the file. So this is question number one. We cannot find a suitable loader out there, and then most of the software that we discovered is actually parser. So the differences between a parser and loader is loader will tear down everything, put it together, and let the CPU execute. Parser is just to understand the file. So parser don't really fulfill our requirements. So we need to build a ELF loader. We need to build a PE loader. We need to build a macro loader from scratch. Okay, PE loader, yes, we do borrow libraries from here and there. And for macro and from ELF loader, we need to build it from scratch. of course, followed by all the syscall emulator. So whichever ELF binary that we test against, we need to fulfill the syscall. So we started with 1, 2, and then now I think easily we got 120 or 130 syscalls ready. Okay, so we call it the POSIX series. It's just because there are quite a fair bit of syscall can be shared between Mac OS, Linux, or the BSD series, right? So for Linux, it's quite easy. I mean, we have shellcodes, we have we have source code, we have informations. We just need to understand a bit more on the kernel, then we can emulate the syscall. Okay. We are still looking for option that we might be able to skip or forward the syscall, and then how can we prepare executions report. So that is part of the syscall implementation that we have been doing. So as you can see, there are some parts of the syscall we actually emulate quite nicely. All right, and there are some parts, especially the mprotect. It's not really important in our scenario, so we just return a 0 and tell the CPU, we are set to go. So if the CPU asks us to protect a certain memory, and we just tell the CPU we actually protected, and we are not going to protect any memory that the CPU asks. So, and then in Windows, we got a more complicated game over here. So in Windows, we need to set up TEB, we need to set up PEB, and then we have these LDR data structures, and then we need to set up the MSR. So bit by bit, we need to set up on hand. All right, there are some codes over here which is kind of outdated. All right, hopefully Quinn don't see it. And in Windows, then we need to build the in-memory module list, to initialize all the lists. These are all the things that we have information here and bit here and there a little bit, but most of the information we need to go through some sort of reverse engineering via IDEA Pro or whatever debuggers that we think is appropriate to get the informations that we need. So we talk about the Linux part, we talk about the POSIX part, we talk about the Windows part, and we talk about the CPU adventure. So once we sort of have the very basic version of the loader, we discovered that we need to set up quite a fair bit of information on the on the CPU. So it's CPU, so it should be OS free. But in certain situations, certain OS required a different setup. So you're looking at x86 3264-bit. You're looking at x86 32 bits GDT, and then x86 64-bit. You need to set up the MSR record. So it's a little bit different from OS to OS, but generally it's still the same. So that is how we need to dig out the information, and apparently it's not too hard. There are quite a fair bit of GDT information, especially to set up inside Unicorn, available out there. So just need to do a bit of reading. And when it comes to ARM or ARM64 series, there is a way we need to inject some code into the kernel in order to activate the kernel. So these are the value is been fixed, all right, inside the kernel, and there's no way we can emulate it. So we decided to extract all this code from the kernel and then to execute it. Of course, ARM64 to enable VFP, virtual floating point. So that's additional steps we need to do. And one good thing is Unicorn Engine already have all this data ready. So we have then we need to figure out how to identify when we goes into situation whereby it's a TARM or ARM mode. Okay, and then make sure the loader is compatible for ARM, for ARM64, for x86, for MIPS, for all the architectures that we wanted to support for Linux at least. Okay, and ARM, like what I mentioned just now, the MCR TLS, the ARM kernel initialization, and then the virtual floating point. Then we move on to a MIPS series. So what do we have over here? It's I still remember this, but okay, this one does bring me enough memories. We stuck in this stage for almost 2 weeks. We try to debug our code, and we look at our code, and until the end of the day, we discovered that there is something that it didn't being enabled inside Unicorn engine. So we look through the QEMU code, and then we extract out the data we want, and it ended up we need to submit a pull request to a Unicorn engine to enable this CP0C3 features. All right, this CPU 0C3 features to enable the then we will have the subthread area ready for MIPS 32. Okay, it's still ELO here, and now we support EB also. So we support little endian, we support a big endian. Okay, so I'll go through the demo setup a little bit, and then Simon will come in to do some demos for how he actually defeated the malware tracking and a malware itself. Okay, so to use Qiling, it's very simple. What you need to do, it's you can use a Python script, or like what I showed you earlier on, you can use a tools called QL tools to run exe file, to run ELF file, or to run a macro file by using QL tools or using this method. So import the Qiling library and then to run with your file name, your rootfs. So your rootfs is technically your jail environment. So what do you have inside rootfs is all the your /bin/etc/lib/lib64 and so on and so forth. Okay, and then do you want to turn out debug type or not? Okay, so that is your your script, the basic version. And the slightly improved version, okay, the slightly improved capability that you can build with Qiling is if you want to disassemble, of course, we have this disassemble features inside Qiling. You don't have to do this, but you know, for the sake of discussion or the sake of sharing with you, you can run the ELF file inside your together with your rootfs settings, and then you can see ql.hook, the last second line from the black screen, ql.hook code, and then we can actually call a function. So the function is the place that started to dump the opcode, and then to print out whatever data or whatever assembly code that you want. So this is part of the instrumentation or redirecting the execution to do whatever you want to display more data. We also are able to do firmware analysis. So we can emulate platform. All right, we can emulate platform and we can emulate so let's say MIPS firmware. Okay. So on the black screen, okay, on the black screen on the left, that is the execution for different syscall. What does it read? What does it run? What kind of syscall does it call? And then on the right screen, you can see the browser is actually displaying the entire router itself. So it's a Netgear R6220 series, one of the router that we test and mess a lot with, because it have a couple of nice features that we can test, especially, you know, XECV is multi-threaded and so on and so forth. So with firmware emulation, what is not easy from here is firmware emulation, especially for CAMs or for routers. There is a lot of devices that you want to look at. So you might need to look at there are certain parts they require NVRAM. So how we can emulate NVRAM or how we can emulate certain devices. So since we control the CPU and since we control the CPU, we control the OS, we can actually feed in the information to the firmware during emulations to fulfill the request, and then this is how we can bring up the entire firmware. I'm not too sure whether Dominic it's looking or not. He pushed in a example how to make Qiling as a fuzzer, a cross architecture, cross platform fuzzer. Okay, for then you can actually fuzz Windows PE inside Linux or fuzz any IoT firmware inside Linux. So the fuzzer everything is actually quite ready and is quite usable. Simon actually provide these very cool features. So we can do a malware analysis, all right, and then we do have OS profiling features. So what you can see over here is you can set your PC name, you can set your Windows version numbers, your language version numbers, your serial number, your path, even your IP. That is one of the pull requests we received this morning. So from Jeremy Humble. And then Simon actually wrote a very nice randomized configuration. So every time we execute a malware, you can have a randomization wrapper to change the username, to change the IP address, to change whatever configuration that you need to fulfill the malware's requirement. So the malware will not know it's actually running on one PC or multiple PCs or different kind of environment. All right. Of course, you can attach a GDB or whatever debugger you want. Okay. So the debugging part, all right. So you can run Qiling in Linux and debug with your favorite IDA Pro or you can even use Qiling to run an exe file and to debug with a GDB. That is up to you on your preference on what to choose and what to run and how to run it, or what to debug and how to debug. All right. So I will not talk about a lot of on Grand Cap, so I'll leave it to Simon to do it. And the ultimate sandbox tester, so I'll leave it to him. All right. So let's pass it over. Okay. Back to you.
Okay, my screen should be visible. Okay. So first of all, who am I? My name is Berni. I'm a master student of Unibo, University of Bologna in Italy, and I'm doing my master thesis in binary emulation and evasion techniques with Certigo. So we decided that Qiling was a good starting point. So for this reason, I decided to join the Qiling community on March, and then tried to improve how Qiling behaves against the real-world samples. For this demo, I decided to bring Alcazar and GandGrab. The first one, Alcazar, is a proof of concept malware that he used to see if the sandbox is configured good enough to not be detected by the sample. And GandGrab is just a simple ransomware. So let's start with Alcazar. I just want to show you how Qiling behaves against a real-world checker that checks if we have every single value set in the correct way, if it's not configured, which is the problem. And so first rule, we can't emulate everything. I will show you that we still have to patch something because we still have some problem, but we have some bads, we have some problems, but again, I think I started working on Alcazar 2 weeks ago, if I remember correctly. So there is still a lot to do, but this is a good starting point. Just for your knowledge, I just had to patch some values because I just decided to note them. And since we have a problem to the print of the results, I decided to just hook this address and check myself if the value is good or bad, exactly how Alcazar would have done. But more important is GandGrab. GandGrab is a famous ransomware, and it's quite easy to understand what it wants to do. So it was my first real-world example that I tried to emulate with Qiling, and at the start I had some problems, but after a bit, after implementing every single API calls, I could do some emulation and have some results. Since we can't, again, emulate everything, and since I decided to stop at some point, I just have to put annotators at the end where we want to stop the emulation. These hooks I will talk in a bit, it's just for an explanation. And what I want to talk about in GunGrab is the profile. I will talk during the setup. So at the start, we have our configuration, our profile, and how it's configured to launch the malware. So for example, we have this computer name, we have the permission, we are launching as root, we have the parent PID, because for example, even Alcazar was checking if the parent process is Explorer XE or not. We have the path, we have the registry, where we can select where the difference between the registry at the start and at the end of the execution. And we have some information about our hardware. I don't want to give this demo explanation of what GunGrab does. Internet is just gives enough information, but just some points. For example, at the start we can see that it's trying to check every single process in our machine, and by doing that, it's comparing the value with some value in this memory. But since again we can't emulate every single process, we are retrieving just a null string, so it's not passing every single check. If the check was correct, GunGrab would try to terminate this process, and we can see how to use Qiling for the check this behavior. More than that, is checking the Windows version. Again, we have configured Windows 10 as a standard, and since the check is okay for GunGrab, we continue its execution. Then it's checking the information about this permission. We are launching GunGrab as administrator, so it can continue its execution and will try to encrypt everything. If it was as a user, again, we can see this behavior thanks to Qiling. Then it's trying to check some keyboard layout. GunGrab is famous to be scared about Russian keyboards, and exactly this line we can see that it's trying to compare my keyboard that I have configured with the Russian one. Again, we can check. We can see how this behavior works. More than that, we can start to see the first run against HandLab and a memes with some insults on it. But more than is important to see that how we can retrieve this information thanks to WSPrintfW. Since we had to implement every single API call, we had to create them. We have even this output. And from what I know, don't take my word as a rule, please, as WSPrintf or printf in general can be used to move memory from one place to another, can be used to create a shellcode, can be used to create more function. So we can retrieve this information, and I think can be quite useful to a malware analyst. More strings. Is trying to retrieve some information about the lock. Again, more information about our registry. And at the end, we can see that it's trying to compare again with some antivirus to see if they are running on our machine or not. Again, we are not running any antivirus because we are emulating it. And at the end, we can see that it's trying to retrieve information about our volume and our disk drive, and storing every information that he knows in a structure. Since, again, we are capturing even the string compare, we can retrieve this information. This is our PC user, this is our PC name, and this is my keyboard. So what we can do? First of all, let's see how GunGrab behave if, for example, we have some process. We can just do a simple look. We'll change that we have always the open process retrieve a valid handle, and the string compare, if checked with a SQL agent, we return a valid value. So we can launch it. Hooks are loaded after the setup part, so after the DLL we can start to hook every single address, every single value, every single syscall that we want. And we are working on a way to not have to load every single time the start of Qiling if you want to launch the same binary with a different configuration. But here we can see that it's comparing, the value is true, so it tries to open the process, is returning our invalid handle, our false handle, and is trying to terminate it, kill it. So let me set it again. It's invalid. Now, let's change profile. What we can do with another profile? For example, what happens if you are running this binary with, I don't know, user, for example, Windows user. The difference with the profile of the standard profile, I would say, is just the single line. Permission now is run as a user, and malware, or by the way, binary in general, its behavior is different if they are run as a user or a root. And we can retrieve this information even with Qiling. If you are run as a user, the get token information will retrieve, since it's brought in the memory, another value. And the behavior is different than what we saw before. So it's trying to retrieve the shortcut name of itself, gungrab. It's trying to retrieve the information where it is WMC, and is trying to launch itself as a shell command with this parameter and the file WMC. So again, we can't emulate everything. We know that. But we can't emulate, so the shell execute, we can't emulate another execution of gungrab. But at least we know that what it's doing, what it's trying to do, is a lot of information for a malware analyst, even if he can't retrieve the second execution, because we know that it's execute a shell command as a run as, so as administrator, and is creating the window. More than that, we can change even registry just using the profiles. So if we use, for example, this profile that is run as administrator and as registry, we have if the sample asks for this key, we'll return that value as default value. If we don't, we can not put any single registry, and we'll just use the value, the default value of the registry passed as an argument. But we can override them in this way. So again, we can see that it's trying to check the keyboard layout. This time, the value is the Russian one, and gungrab doesn't like it. Doesn't like it at all, because it will kill himself. That's because, from what I read online, I'm sorry, but I'm not an expert on this field and I'm still learning, but it doesn't want to execute in any kind of Russian environment. So if it checks that Russian language or an Eastern European languages or a Russian keyboard, it will just kill himself and stop the execution. That's it. It's not complicated at all to use it, and just for your knowledge, how it's configured profile. It's a simple, we use config parser, if you know that library, to check what is inserted, and it's simple as that. It's not everything is in this way. It's possible for malware analyst just give many configure of your entire system, many profiles, and change the behavior of the malware and analyze the malware in different behavior, in different, I can say, environment. If you have, I don't know, a Windows 10 machine, but at the same time you have a macOS, you want to check both the environment. We are working on macOS profile. And that's it, pretty much. I can give back the word to Kai if I think he has more examples, so I can stop the presentation.
Oh, too bad we don't have time. I have tons of I do have tons of demo.
You get to choose. You have about 3 minutes. There were no questions there, so if you have a short demo, I would say throw it in.
No, we don't have a short one. We still have a few more slides. Okay, so let's cover the few more slides. All right. Yes, I copy Apple again. One more thing. It's this should be a conclusion slides, but I don't make it a conclusion slides. I turn it to a star bagging slide. So we are feeding on star, ladies and gentlemen. Again, please like our project, give us a star, commit to the project, send us more pull requests. Okay. Right before the talk, 5 minutes. Right before the talk, we tag 1.0. So officially, this is the day that we ended our beta, our RC, and we goes into a proper 1.0 version. And I did discover a bug after we tag, so screw it. We're gonna do a 1.0.1 later next week. All right. So we do hope to see more exciting binary analysis tools on top of Qiling later. Okay, after you guys look at our project. And we are proud. We are still very proud to say that until now, we know that for sure. I mean, in the situation that we actually know, we know that there are couple of thesis is either on their bachelor degree, on their master degree. It's actually the entire thesis is built on top of Qiling. We are very happy to hear that. So if anyone really using or writing a thesis, or helping you in your day-to-day life on malware analysis, on IoT analysis, please do let us know. Quinn sent me a message to show you, to ask me to show you guys the address. I guess you can see it over there. It's qiling.io. Click on download, then you go to our GitHub page and click on the star. All right. So the very last message that I would like to share, it's ever since 2015, okay, the lazy Quinn, he released Unicorn 1.0, and then until now, I think he tried to move to 1.02, and there's no news. And after quite a bit of collaborative pressure, okay, we forced him to go to Unicorn 2. So finally, he decided to go for Unicorn 2, and then we are still looking for sponsors. Open source project, it's a very money burning project. So we hope we were able to get sponsors or any help that I can actually help on Unicorn 2. Okay, so he sent me a message again. He said, "Damn it, you asshole." Okay, basically that's it. That's our talk tonight, and I hope you like it.
Okay, awesome. So thank you, Kay.
Did I share my screen just now? No.
No, you did not.
Oh shit. Anyway, I'm idiot. I am an idiot, but there's only 2 screens, so anyway, it doesn't matter. Okay, let me show it now. No wonder he says I never share my screen. Do I have like half a minute?
Yeah, half a minute.
Okay, so yes. You can see qiling.io, or just go to GitHub, Qiling framework /Qiling. Then you can see the very big red star arrow, and then like star or project, or else I will not leave this live stream until I see 1,000 stars. I'm just joking. Okay. So questions?
We don't have time for those, so but I'm still going to thank you, Kayen, for your talk, and Simone, thank you very much.
Thank you.
And yeah, people, be sure to start their project.